So what we're going to do is we're going to learn about simulation. And the first one is the PortaCom project. So what this looks like is you're going to have a bunch of different inputs if you're trying to do a simulation. So the goal is you want to have some sort of model. And that's going to give us the output that we want. So we're going to need to figure out actually what is the model. And what goes into the model is really two things. We have controllable inputs and then we also have uncontrollable inputs. So controllable inputs, those would be something like you know what the rent's going to be. So you can control that price. Uncontrollable would be something like demand. If you don't know how many people are going to buy the product, we might have an idea, but that's not really in our control. So that's what we mean by controllable versus uncontrollable inputs. But we're going to somehow develop a model out of this and then get an output. And our goal is we want to play around with all the inputs to see what can happen to the outputs. So the way that this PortaCom project is set up is it's a company and they provide electronics. They want to build new printers, but they need to know how many of these printers should we build. So our question for them, or the question they're asking us, is how many of these printers should we do? What they do know is that they know the selling price is going to be $249 per printer. They know that the administration cost is going to be $400,000, and they know that the advertising cost is going to be $600,000. What they don't know, though, is they don't know the direct labor cost, the parts cost, and the demand cost. They have estimates for all of those, but they don't actually have concrete numbers. What we're going to do is we're going to figure out some sort of simulation to see what's the first year profit. Now, as far as profit goes, we're going to let X be the number of printers. And that's our variable. How many printers did they actually do? For our equation for profit, we need to figure that out. We know that the cost per printer is $249. So the money that we're going to have coming into us is the 249 times X. But then we're going to have to subtract off the labor cost per printer. So labor times X. Again, we don't know what the labor is going to be. We're going to have to subtract off the parts cost times X. Again, we don't know what those are. And then also the 400,000 and the 600,000. So the admin cost that we already discussed, and also the advertising cost. And we could combine these, of course, and say that really we're subtracting off 100,000. Sorry, million, not 100,000. So this is going to be our equation for profit. The only issue is we don't know what the labor is going to be. We also don't know what the parts are going to be. And we also don't know what is X going to be. I mean, X is the number of printers that we're going to sell. This is also called our demand. As far as labor costs go, what's happened with this company is that they've figured out that the cost has a certain probability. Right, so there are certain costs that could come from these printers. Either the printer is going to cost them $43 to build, sorry, this is the labor cost, $44 for labor, $45 for labor, $46 for labor, or $47 for labor. And each one of these has an associated probability. So there's a 10% chance that it's going to cost them $43 for labor. There's a 20% chance it's going to cost them $44. There's a 45% chance, so that one's the most likely. Or 40% chance it's going to cost $45. And then there's a 20% chance it's going to cost $46, and a 10% chance it's going to cost $47. So what they've done is they've looked at this based on past experience. They don't 100% know what it's going to cost them, but they have probabilities associated with it. They also don't know parts cost, but what they do know is that it's uniformly distributed. It's uniformly distributed between $80 and $100. Now what that means is that we don't know what the cost is going to be. It's somewhere between 80 and 100, but everything between 80 and 100 has equal chance of happening. As far as the picture goes, if you want to think of this as a graph, the cost is between 80 and 100, and because we know probability has to add up to 1, each of these has probability 1/20th of happening. They also don't know how people are going to react to this product, so they don't know what the demand is going to be. But what they do know is that the demand is going to be normally distributed with mean 15,000 and standard deviation 4,500. So the average demand is going to be 15,000, and we know that that's probably going to sway 4,500 either way and be most likely. So we're going to use all this information to run some simulations, and we're going to do that in Excel, which I'll do in a separate video. The question is, can we estimate what will happen? So I want to go through a couple things before I actually put this into Excel. The first one is, if a variable is using the normal distribution, so for like demand, we know that we had a mu, and it was 15,000, and I had a sigma that was 4,500. I'm going to need to somehow come up with a list of likely demands. And I don't want to do that manually. So what I can do is I can use a norm inverse command. And the way I can do that is take a random number. That's what this command means in Excel. This is just a random number between 0 and 1. So take a random number. You don't need anything inside the parentheses, just rand, open parentheses, close parentheses. Then your mu and your sigma. And what this is going to give you, it's going to give you a list of possible demands where the mean was 15,000 and the standard deviation is 4,500. So that's one thing that we're going to need to know. Second thing, for the parts cost, if you're trying to figure out a bunch of different parts costs that are likely, one way to do that is use the formula, because it's uniformly distributed, A plus R times B minus A. A is going to be the lower number. For us, that's going to be 80. B is the upper number. For us, that's 100. And R was the probability. Because we're trying to generate a bunch of different options, for us, again, this is the rand and open parentheses. So this will give us a number between 0 and 1. We'll multiply that times B minus A, and then we'll add that to A. What this is really doing is it's starting at 80, and then it's adding a little bit each time, but it's never going to go above 100 because this R is between 0 and 1. So it's giving you numbers from 80 up to 100, and they're all going to be just as likely. Third thing is about this labor. So labor was interesting because you had this table. So what we're going to do in Excel is use an if command. So in one column, which you'll see in just a second, we're going to generate a random number between 0 and 1. Right? So we could have numbers like 0.1, 0.3, 0.48, I don't know, 0.2, whatever, 0.7, 0.9. We're going to have all of these. And we need to somehow associate a labor with each one of them. So what we can say is that because 10% of them would give us a 43. So if you go back to that chart, 10%, or the probability of getting 43 was 10%. We'll say if the random number is less than or equal to 0.1, then the labor cost is 43. Because we want 10% of the numbers to give us 43 as the cost. Now if that doesn't happen, and I'm going to write it on the next line, you're not going to write it on the next line, but I think it makes more sense for me to do it here. If your random number is not less than or equal to 0.1, so now I'm looking at the next one on the chart. So 44 had a 20% chance of happening. So if it's less than 0.1, 43. If it's less than or equal to 0.3, so now I've added 20%, then I want the cost to be 44. So this is saying it's not less than 0.1, it's between 0.1 and 0.3, then 44. For 45, that had probability of 0.4, so we'll add that in. So if it's less than or equal to 0.7, then the total cost is 45. If the random number is less than or equal to 0.9, so that was my 46, and if none of those happen, so if it's not less than 0.1, not less than 0.3, not less than 0.7, not less than 0.9, if nothing else, then it's 47. So that's going to be my labor cost. And that's what we're going to put here. So again, this if command, it's if, and then you'll test something, then you'll have an output. And then the last thing is, if the output doesn't happen, then this is the else. So if whatever your test is, do this output. If it failed the test, then do something else. So on this first one, if the random number is less than or equal to 0.1, then output of 43. But if it's not less than or equal to 0.1, then do this other part. So that's how this whole if then works.